Hey everybody, this is the last section of chapter 5. This is 5.6, applications. You know what applications mean, right? Means word problems and other stuff. All exciting. So we're going to start with ratio problems, ratio and proportion. When something's in a ratio A to B, you can think of it as a fraction. A to B is same as A over B, or you can write it as a ratio or a division, okay? An equation that equates two ratios is called a proportion. So what a proportion says is that this ratio is equivalent to this ratio. Okay, A over B is equivalent to C over D, two equivalent ratios. So when we solve a proportion, this probably feels a little familiar for you. There's lots of ways to do it, but the easiest, well, sort of the most consistent really, is to cross multiply, which we can do across an equal sign, right? So we can do 5 times y equals 19 times 95. 5 times y equals 1805. You have a calculator, you can use it. And then divide. Divide by 5. Y equals 361. So at that point, when you get an answer in this, you should like pause and make sure it makes sense. Like 5 times 3 is give or take 19, 5 times 4 almost. If I did 95 times 4, you know, it'd be a little less than 400. That makes sense. So stop and actually, when you do these things, make sense of your answers a little bit, just to make sure you didn't do something silly. The other thing you can do is that if you did 19 times 95, you should get 1805. You should also get that when you multiply 5 times 361. And let's check that we do that. I don't have the right thing in front of me, which is my calculator. And I do. Okay. All right, let's try another one. This one goes the same way. I'm not going to do this one, but I'm going to tell you that when you get x, it should be 15 over 2 because you have to simplify the fraction. Okay, cross multiply, divide. This is a similar kind of question. It just happens to have words in it, I know. The recommended ratio, okay, when you see that ratio, you know what to start thinking of. Total cholesterol to HDL is 7 to 2, okay? Rich's blood test revealed that he has total of 210. What should his HDL level be? Now, when you see things like this, if you need to write them in words first, that's fine. I think of this, you know, this is how I think of it. I think about he's got his HDL, cholesterol, and he's got a total, right? So when I set up my proportion, that's where my parts are going to go. The recommendation is 2 to 7. And on the other side, Rich's is total, he has 210. So what part of that should be HDL? Well, here's our proportion. Did I put everything in the right place? Yep, so this is HDL. These are totals on the bottom. Okay, so then the same thing to solve. 2 times 210 equals 7x. This is 420 equals 7x. 420 divided by 7 is 60. So, and that makes sense in the context of the story that it's less, right? All right. The ratio of cats to dog in an animal rescue facility is 8 to 5. How many dogs are there if there are 400 cats? Well, let's say we told us cats to dogs, right? So we know 8 cats for every 5 dogs. I don't know how many cats. Oh, sorry, I do know how many cats. I don't know how many dogs. I do know how many cats. It's a lot of cats. Let's find out how many dogs. So 5 times 400 is 2,000. 8x divided by 8. X is 250. And that makes sense. There should be fewer dogs, right? All right, let's try another. The ratio of male to female police officers in a town is 11 to 3. So that's male to female. It's 11 to 3. If the total number of officers is 112, how many men and how many are women? Well, that's so I didn't have a total here. So if we think about it, for every 11 male police officers, there are 3 women. So for a total, that gets us to 14, right? Once I have that, I can start figuring out how many men and how many women. Because I'm going to think about whatever, let's do men first, okay? Men out of the total. I know the ratio is 11 to 14 men out of total. So I don't know how many men there are, but I know in total there's 112 people. So for that one, I'm going to do 112 times 11 equals 14x. 112 times 11 is 1232 equals 14x. Divide by 14. X is 88. So now you can find the number of women. You can set up another proportion and use 3 instead of 11, or you can go 112 minus 88 is 24. 24 women, 88 men. Okay, not terrible. This one works the same way. Okay, I will tell you that, let's see, it says Professor Wolf has a ratio of passing students to failing, of 5 to 4. Ooh. One semester he had a total of 207 students. How many passed? How many failed? Well, I will tell you that 92 failed and 115 passed. You try it. If you get stuck, drop your questions into the discussion and let's talk about it. All right. Proportions are also something we can use to figure out similar triangles in geometry. Remember that similar means they're the same shape but not the same size. Okay, they're proportional sides. They still have to have the same angle measurements, so their corresponding angles are equal, but they don't have the same length measurements. Here's an example of proportional triangles, right? So this C and Z are proportional because angle B and angle Y are the same. A and X are proportional. Z and C are the same. And then B and Y are proportional. A and X are the same. Okay, so now let's use something like that to help us. A shadow cast by a yardstick is 2 foot long. So let's think about it. We have a yardstick in the ground and it casts a shadow. That's 2 feet. Okay, it's interesting. We already have a problem though. This is a yardstick and this is in feet. How many feet are in a yard? If you don't know the answer right away, go figure it out. Okay, so there's 3 feet in a yard. So that's 3 feet. Then it says the shadow cast by a tree is 11 feet long. So we imagine they're in the same spot. This one's 11 feet. Okay, what we don't know is the height of the tree. You've seen problems like this before, right? We're going to set up a proportion. So x over 11 is the same as 3 over 2. X over 11 is the same as 3 over 2. Yep, 2x equals 33. Divided by 2. The height of the tree is 16.5 feet. Make sure you change feet to yards, or yards to feet. All right, in this one, it says triangle XYZ, this guy, is similar to triangle ABC. It means their angles are the same and their corresponding sides match up. They're proportional. Find x. Well, in triangle XYZ, I have 9 over x. And that relates in the other triangle to 3 over 4. Solve the proportion, I should get x equals 12. Okay. All right, let's try another. This is where it starts to get a little different, okay? An athlete's average speed on her bike is 14 miles per hour faster than her average speed running. Okay, so that makes sense. She goes faster on a bike than she does when she runs. That's a good thing. She bikes 31.5 miles in the same times it takes her to run 10.5 miles. God bless her, she ran 10.5 miles. Find her speed running and her speed biking. Okay, so Whoa, there's a lot to take apart there. We want to find her speed, right? We know something about her bike speed is 14 miles an hour faster than her running. So we need an x. X is going to be her speed doing what? Well, the plain x is going to be the speed she runs. We know she bikes 14 miles an hour faster than that. All right, so that helps. So now we have proportions, right? We can talk about bike. We can talk about run. So let's talk about it. Her speed on the bike is x plus 14. Her speed when she runs is x. She goes 31.5 miles when she bikes, and the same time it takes her to go 10.5 miles running. Well, now we can do this, right? It's just cross multiply and divide. So I get 10.5. It's just a little more complicated, right? Equals 31.5x. So 10.5x plus, what's 10.5 times 14? It's 147 equals 13.5x, or sorry, 31.5. I'm getting my numbers backwards. Combine like terms, let's move the 10.5x over. And then I get 147 equals 21x. So divide by 21. X is 7. All right, so that tells me when she runs, she goes 7 miles per hour. When she bikes, it's x plus 14. 7 plus 14 is 21. All right, I have faith in you. You can do this. Let's try another. Devin can cross-country ski 5 kilometers an hour faster than his sister. Devin skis 45 kilometers in the same amount of time Chanel skis 30. Try this one by yourself. See what happens. Remember to define x as the one you know less about, right? So take a minute. I'm going to do the defining and setting up. You do the rest. So I'm going to define x as Chanel's speed. I'm not going to write that all out, which means Devin's speed is x plus 5, right? So now let's see. I can do Devin over Chanel. So he is x plus 5, and he goes 45 kilometers. Oh, sorry, that's in the wrong spot. It could work out this way too. There's a couple ways to set up a proportion in any given moment. And he goes 45 in the same amount of time she goes 30. You can do this. What you should figure out is that Chanel's speed is 10 miles an hour and Devin's is 15. Which is pretty good on skis. Okay. If you get stuck, once again, head into the discussion. All right. This is the next 4 problems that we're going to do are the more complicated ones of these. You can figure these out. You're just going to have to be a little patient, okay? And if you need to watch this a couple of times, that is okay too. There's just some structures to think about here. So Valentina goes 70 miles to Rome by train and then takes a bus 30, or not miles, kilometers, 30 kilometers to the Colosseum. The bus goes 24 kilometers per hour slower than the train, of course. And the total time traveling altogether is 2 hours. What is the average speed of each? All right, so first we need to remember something. We're talking about speeds and how long it takes and how far we went. There is an equation that relates all of that together. It is distance equals rate times time. Okay, that's one of those things you should have in your pocket and just kind of know. And when you see a story like this that's all about like different distances added together in a certain amount of time and speed and all this, this is the equation that should come to mind. In this case, we know something that the total time is 2 hours. So the lovely thing is I can sort of reorganize this equation to make it time is distance divided by rate. We can use it any way we want. So now let's think about some things. Let's think about the distances, the rates, and the times, okay? We know, what do we know? We know it takes her, let's see, how far does she go on the, wait, I need to put my train and the bus, right? She goes 70 kilometers on the train. She goes 30 kilometers on the bus, right? The rate, the speed, the one we know is the train is X, bus is 24 kilometers per hour slower, okay? If we think about the time, time is distance divided by rate, okay? So I could do 70 divided by X, that's the time, equals 30 divided by X minus 24 is the time for that, okay? Now, what I know is that this time, these two times, the time she spent on the bus plus the time she spent on the train equal 2 hours, right? So now I can say that. So I have 70 over X plus 30 over X minus 24 equals 2. It's crazy, right? All right, so now we need to do some stuff. This looks a little familiar from the last couple of sections, doesn't it? It looks like I need a common denominator. So least common denominator here is not X minus 24, right? It's the factors that are unique. X minus 24 is one factor, plain old X is another. So the least common denominator is X times X minus 24. So now what do we do with that? We use it everywhere. Same here. I'm going to apply that there. I just ran out of space. So in this case, X cancels. I have 70 times X minus 24. In this case, X minus 24 cancels, plus 30X. And on this side, I have to use them all. So 2 times X minus 24. Bummer. Okay. All right, so now let's do the algebra part of this, right? So distribute combine like terms. So I get 70X minus, what's 70 times 24 is 1680 plus 30X. On this side, I get, let's see, that's X squared minus 24X times 2. So it's 2X squared minus 48X. Yeah. All right, so let's see. I'm going to move, you see an X squared in here? I'm going to move everything this way. So minus 70X plus 1680 plus minus 30X. I'm still using an eraser. All right, so on this side, I'm going to have 0. On this side, I'm going to have 2X squared. Let's combine my X's. Minus 30 minus 70 minus 48. Minus 30 minus 70 minus 48 is minus 148X. And then I have a plus 1680. All right, now you see where we're going. We're at the factor stage. I have to make my page a little longer. All right, so everything is even here. Let's pull out a 2. So I get X squared minus 148 divided by 2 is 74. X plus 840. Take a minute, do some factoring. Don't lose your 0 and your equal sign. All right, so the 2 stays here. I will tell you the factors here should be minus 60, pardon me, and minus 14. All right, so we said 0 equal to 2. That doesn't work, so we don't have to pay attention to that. Then we have X minus 60 equals 0. We have X minus 14 equals 0. So X is 60 and X is 14. Well, what makes sense there? So now we need to think for a second. We need to go back up to the top. The speeds, let's see. The rates, it could be either 60 or 14. Well, if it's 60, that makes this 60 and this 36. That works. If it's 14, it makes train 14 and the bus negative 10 miles an hour. That's crazy. So it can't be 14. It's got to be 60. So her speed on the bus, sorry, on the train is 60 kilometers per hour. Her speed on the bus is 60 minus 24, 36. Okay, I know that's complicated. There's a lot of moving parts, but that's kind of the hardest version of this right here. You can do this. Let's try another. We're going to set it up the same way. Jason drives 50 miles to a train station, then continues with this trip with a 210-mile train ride. The car is 20 miles an hour slower than the train. If the total travel time is 4 hours, let's find the average speeds. Okay, so let's remember we're going to do time equals distance over rate. My marker doesn't want to do that. So let's set it up. He goes by car and he goes by train. And what do we know? Distance, rate, time. So in the car, he's going 50 miles. On the train, he's going 210. The train is the one I don't know that much about, and the car is 20 miles an hour slower. The time is distance divided by rate, so 5 over x minus 20. And 210, or sorry, 50 over x minus 20, and then 210 over x. These two things together make up the total time, and the total time is 4 hours. So 50 over x minus 20 plus 210 over x equals 4. From here, you need to do the math, okay? I will tell you that when we get it all figured out, the speed of the train is 70 miles an hour, and the speed of the car is 50, the average. All right, figure it out. If you get stuck, ask a question, ask your partner, ask in a discussion, ask somewhere. All right, one more kind of problem. These are referred to as work problems, okay? So in this story, what happens typically here, let's read the story. Joanne can wallpaper a bathroom in 3 hours. Bonnie can wallpaper the same bathroom in 5 hours. How long does it take if they work together? So the thing to remember here is that the speed that Joanne does the job, okay, the rate, right? And the rate that Bonnie does the job together equals one whole job. When they work together, they do a whole job at whatever speed total, okay? So if I think of this as, you know, a rate, right? Work and amount of time. Joanne is gonna do a certain amount of work, and normally it takes her 3 hours, right? So it's gonna take her a portion of 3 hours. Bonnie does a certain amount of work, and it takes her 5 hours, okay? This X is the total time together. This is how long it takes them in total. And when they are done working together, they do one whole job. Okay? This is in hours. Now, this is not horrible to solve, right? Common denominator. Okay? So the LCD here is 15. And then clear out the fractions. So multiply everything by 15. Let's see, that becomes a 5, that becomes a 3. So we get 5x plus 3x equals 15. 8x equals 15. Oops, divide by 8. X is 15 over 8, which is the same as like 1 7/8. So it takes them a little less than 2 hours to do the job together. And that makes sense because it's faster than Joanne would be working alone, but Bonnie was slower, so she only helps sort of, right? All right, let's try another one. Antonio can install a new roof in 4 days. Bob can do the same roof in 6 days. how long can it work if they work together? So it's however Antonio works plus however Bob works, and they're doing one roof. Okay? So X is total time together. In our units is days, right? It's important to remember units so that you can finish your story and make sure you got it about right. So Antonio takes 4 days to do his part, but when he has help from Bob, who usually takes 6 days, this is how long it's going to take altogether. All right, well, least common denominator is 12. I know you wanted to say 24, but it's 12. 24 would work too, though. It's just more multiplying. All right, so that's a 3, that's a 2, that's a 24. So 3x plus 2x equals 24. 5x equals 24. Divide by 5. X is 24 over 5, which is what? 4 and no. Yes. No, 24 divided by, what did I do wrong? Something. Where'd it go? My brain. Oh, I see what happened. I'm sorry. My brain was talking about 24, and so I used it instead of 12. I know you probably saw it when it happened and were yelling at me. 12, 12, 12. You see how I noticed my mistake, though, right? Because it doesn't make sense for it to take longer for them to work together. Aha. I was talking about 24, and I used it. So times 12. 12, 3x plus 5x equals 12. Divide both by 5. 12 divided by 5 is like 2 and 2/5, right? So together, it takes them 2 days and a little more to do a new roof. All right, so you're going to practice these. You from here are also going to do the review for this, for the chapter 4 and 5 test, because that's coming next. So work on this section in ALEKS, work on what comes after it. And as you have questions, drop them in the discussion, send them on email, ask your partner, do what you need to do, but make sure if you get stuck that you get help. Okay? See you in the module.